When we try to take limits as x approaches infinity or negative infinity of rational expressions that include radicals, like the one that we see here, x over the square root of x squared plus 1, we can't use the same shortcut formulas that we have for just regular rational expressions. So those formulas work when the degrees we're talking about happen to be integer values, and preferably positive integer values. Things get a little bit different here when we start looking at these things that have radicals with them. So the first question is, how do we even determine the degree of something like the denominator of this when we have the square root of things? Well, what we're going to do is kind of fudge the idea. We're essentially going to apply the square root to the leading term, and if we take the square root of x squared, we'll end up with a term that just has x in it. All right, if there was a number there, we could ignore that. We're just really trying to play with the degree here and just play with it off the leading term. That is the term underneath the radical with the highest degree. So it looks like what we have here is highest degree is really x, or a degree of 1 in the top and the bottom. So what we will choose to do is multiply the top and the bottom by 1 over x. And when we do it in the bottom, we're going to be clever, and we're going to say that we're really multiplying by the square root of 1 over x squared. Square root of 1 over x squared is 1 over x. But by using the square root, we can multiply square root by square root in the bottom. It makes our life a little bit easier. So we're going to end up here with the limit as x approaches infinity of 1 over the square root of 1 plus 1 over x squared. Now, as we've already seen, as x approaches infinity, this 1 over x squared term is going to go to 0. So what we're really going to end up with here is the limit as x approaches infinity of 1 over the square root of 1. But that's just 1. So as x approaches infinity, there is a horizontal asymptote. The horizontal asymptote is y equal to 1. That's the value that the function approaches as x gets extremely large in the positive direction along the number line. Now, let's apply the same idea over here to the negative infinity. Right? When we didn't have the square roots, we just kind of said, well, everything works out the same, and we didn't do an awful lot. But let's take a look at what happens here for a second. When x approaches negative infinity, we're only worried about really large negative values. And if we're worried about really large negative values, this 1 over x here is going to be small. It's going to be kind of 0-like. But it won't be 0, and it'll be negative, whatever it is. When we do the same thing down here, when we square that negative number, it becomes positive, so we end up taking the square root of a positive number. By the principal square root idea, we end up with a positive number. So in the top, we're multiplying by a negative, but in the bottom, we're multiplying by a positive. That says we're not multiplying by 1, like we did over here when everything was positive, but we're multiplying by negative 1. That's no good. That changes things. So what we're going to need to do is insert a negative in front of the square root of 1 over x squared. That'll make sure that the top is negative and the bottom is negative, since our x's are negative, and that's what we want to have happen. And now we're multiplying actually by something that's equivalent to 1. So here's where things get a little bit different, and we just need to think our way through what's going on. So we're going to get the limit as x approaches negative infinity of 1 over negative the square root of 1 plus 1 over x squared. Now, just as before, the 1 over x squared is going to go to 0. So we're going to end up thinking in this case of the limit as x approaches negative infinity of 1 over negative square root of 1, and that's negative 1. So this function has 2 horizontal asymptotes. That's the most that a function ever can have. They can have 1 at positive infinity and 1 at negative infinity. And we have a different one in each one. You probably want to go ahead and graph this function, take a look, and confirm for yourself that this thing does end up having 2 different horizontal asymptotes, depending on whether we're headed for positive infinity or negative infinity. So, as a reminder, functions don't have to have a horizontal asymptote. They can have exactly 1 horizontal asymptote, or, as we've just seen, they can have exactly 2 horizontal asymptotes. But those are the only possibilities, since we only have 2 ends of the number line to choose from to even give us those asymptotes.